Hello. Today we are going over Note 7.1, Introduction to Circles. So what is the definition of a circle? It's a set of points that are equidistant from a given point. So for us, that point is called the center. And again, it's a set of points that are equidistant from a given point. So we all know what a circle looks like, but do you know the equation from which it comes from? So it looks like this. So here's our general form of a circle. So x minus h squared plus y minus k squared equals r squared. H and k is the shift, just like it's been for all of the graphing we've done, right? Our very first unit when we had parabolas and we had exponential, we had lines, we talked about the shift with h and k. So in this case, the center is h comma k, and your radius is just r. So the shift is the center. So h and k is the shift, just like it was from all the other graphs we've done, right? Your shift is the same thing. The key point for a circle is usually centered around the origin, right? 0, 0, until it is shifted. So identify the center and the radius of the circle. So your center would be h and k. So notice, right, if you look at the signs, it's minus h and minus k, and our center is h and k. So that means our center is going to be the opposite signs of the numbers that are given to us in the equation. So for example, number 1, the center would be negative 6, comma 2, because you have positive 6, so it's opposite and opposite. The radius would be the square root of 9, which is 3, because the equation has the radius as r squared, right? It gives you r squared. We want r. That's the radius. So if you look at number 2, nothing added or subtracted, so that would be 0. And then this is plus 13, so the center would be minus 13. The radius would be the square root of 121, which is 11. Okay, number 3. Again, you have minus 1, so you'd have 1. And then there's nothing added or subtracted, so that would be 0. And your radius would be the square root of 19, right, which is about 4.35. Now, we only need to know the decimals because we're going to sketch it. So to sketch the circle, first you plot the center, which in our case is 1, 0. And then to sketch the graph, for me the easiest way is to go right, left, up, down, whatever the radius is, and then connect those 4 dots with a curve. So 1, 2, 3, 4, just past 4, and then up 1, 2, 3, 4, just past it because we're at 4.35, and then left 1, 2, 3, 4, and then down 1, 2, 3, 4. And then just connect those 4 dots with a curve. And there's your circle. So you have your 4 points, right, and your center. And then so that would be your circle. Now do your best to curve as much as you can. Again, mine kind of looks like an oval. Just try your best to make it as circular as you can. It's not going to be perfect. That's not what we're focused on in the unit. So write the equation of a circle with the given information. So the center has been shifted from the origin 7 units to the right and 3 units up with a radius of 81. So the center was 0, 0. Now it's 7, 3. So it's been shifted 7 units to the right. So, right, if our center is 7, remember the center and the value is given is opposite. So this would be minus 7. So if it's positive 3 in the equation, it would be minus 3. Remember, the center and the equation, the signs are opposites. How do I know that? Back up here to the equation, the general equation. You have minus h and minus k. But if you look at the center that I gave you, it's h and k. Those are opposites. Minus h and h are opposites. So the center sign is opposite than the equation sign. And then the radius is 81. So remember, your equation, you write it as r squared. So if our radius is 81, we have to write it as 81 squared, which would be 6,561. Okay, number 5. The center is shifted from the origin 5 units down and a radius of 3 root 5. So the center was 0, 0. Now it's 0, negative 5. So it hasn't moved left or right. So then it's just going to be, you can write x minus 0 squared if you want. But what we're usually going to do is just write x squared. It's always plus. And then for the y, it's been shifted down 5. So again, the center value is negative 5, so this would be plus 5 and then squared. And then our radius is 3 root 5. So remember, the equation is r squared. So to clean this up, we have x squared plus y plus 5 squared equals 3 root 5 times 3 root 5. We've done this before in the class. Right? 3 times 3 is 9. Root 5 and root 5 is root 25, which is just 5. So 9 times 5, so 45. Again, whenever you have a 0, you can always write it as x minus 0 squared if you want, or you can just write it as x squared. Same thing with the y. If you write the 0 in, that's not wrong. It's just usually you won't see that. You'll just see x squared or y squared if the graph hasn't been shifted. So identify the center and the radius and sketch the circle. So our center, right, it's going to be opposite. So negative 3. There's nothing added or subtracted to the y, so it'd be 0. So 1, 2, 3. And then our radius is going to be the square root of 49, so it's 7. So I'm going to go to my center. I'm going to go up 7. I'm going to go right 7. Down 7. And left 7. Just do your best to estimate it. Does it go off? And then we're just going to, since it says greater than, right? Remember, greater than, less than, those are going to be dashed lines. Greater than or equal to or less than or equal to are going to be solid. So this is going to be dashed. And again, just do your best to make it as curved shape as you can, to make it as circular as you can. It's not going to be perfect, but just, put some effort into it. And again, remember, with inequalities, we shade. So it says greater than 49. So it's greater than. So where are we going to shade? Are we shading outside or are we shading inside? Right? Since it's greater than, we would be shading outside. So we would shade out here. Okay, number 7. So notice nothing has been added or subtracted to the x squared, so the center is going to be 0. This is plus 4. Remember, it's opposite, so opposite of plus will be minus 4. So I'm going to go down 4. And then my radius, right, is going to be the square root of 25, which is 5. So I'm going to go up 5, left 5, right, down. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And then again, this is a less than or equal to, so it's going to be solid. So I'm going to connect it with a solid curve. Again, trying to do your best to curve and make it circular shaped. Again, it's not going to be perfect, but just try your best to make it look like a circle. And again, it says less than this time. So less than, that means we're going to shade inside. So there we go. So again, just remember less than equal to, greater than equal to is a solid line. Less than or greater than, remember those are dashed lines. In this case, they're going to be solid or dashed curves. Wait, number 8. The point 0, 1 is inside, outside, or on the circle. Here's the equation. So justify our answer algebraically. So what we're going to do is we're going to take that point, and if it was on the circle, when we plugged in 0 and 1, we should get a true statement. Right? When you plug in 0, 1, it should be 25 if the point's on the circle. If it's not, we're going to get a number either bigger or smaller than 25, and that's going to help us determine whether it's inside or outside. So let's take, we have our x, we have our y. So let's plug in 0. So 0 plus 2 squared plus 1 minus 4 squared. And we're going to see if that equals 25. If it equals 25, then it's on the circle. If it doesn't equal 25, then it's inside or outside. So this would become 2 squared, right? So this would just be 4. This would be negative 3 squared, which would be 9. So 9 plus 4, right, is 13, and that is less than 25. So it's not on the circle because they're not equal. So it's not to the outside of the circle. It's not greater than, it's less than it. So that means we would be on the inside since it's less than. If it was greater than 25, then it would be outside. If it was equal to 25, then it would be on the circle. So another example with that, number 9. So again, is this point inside, outside, or on the circle? So same idea. We're going to plug in 5 for x, and then negative 4 for y. And we're going to see if that equals 36. So 5 minus 2 is 3. 3 squared would be 9. Negative 4 minus negative 3 is negative 7. Squared would be 49. And then, so does that equal 36? Well, no, it's bigger than 46. It's greater than, right? It doesn't equal, so it's not on the circle. It's not less than, so it's not inside. So 9 plus 49 is greater than 36. So this would be outside. So in your Math 2 Days, you learned a process called completing the square. So this is another way to help you try to solve or factor a quadratic. So this is another tool other than using the quadratic formula or factoring or graphing. This is another tool that will allow you to solve quadratics. So we're going to use it to help us rewrite our equation so that we can easily graph circles. So we're just going to start the beginning process today, and then when we work on 7.2, we'll get into it in more detail. So complete the square when writing the resulting equation as a perfect square. Do not solve, no decimals allowed. So in order to complete the square, 2 things have to happen. First, the x squared term, the a term, has to be a 1. If it's not a 1, you have to make it a 1 using division, multiplication, but it has to be a 1. Second thing, you're going to want your constants on the other side of the equal sign. So you want x squared and x on one side and the constants on the other side. So they have this set up for you. So in order to complete the square, you take the b term, which is the term that has the x. Remember, a quadratic is ax squared plus bx plus c. So the b term is the term that has x to the first power. The x squared, the a term, has to be a 1. So we're going to take the b term, in this case 12, we're going to divide that by 2. So that's 6. We're going to square it, and we're going to add it to this side, and we're going to add it to the other side. So 6 squared is 36. Again, what we're doing is we're rewriting our equation to make it look different so that we can actually graph this. And it'll make more sense when we do this tomorrow. This is just an introduction to completing the square. So now what's happened is by taking that b term and dividing by 2, you have created a perfect square binomial. So what does x squared plus 12x plus 36 factor to? Well, that would be x. So multiples of 36 that give you 12 plus 6 plus 6. So really, you have x plus 6 squared. So this is what you just created, a perfect square. That's why it's called completing the square. You're making a perfect square binomial. And then on the right side, you have 40. So we're just going to stop there. We're not going to go any further. We're just getting used to the first few steps. Now, some of you might be asking, well, do I really have to factor that trinomial every time? No, if you pay attention to a pattern. So notice, if you take the b term and you divide it by 2, whatever this is what this is always going to factor to. So notice it's a 6. It factors to x plus 6 squared. If it was a 2, it would be x plus 2 squared. If it was a negative 3, it would be x minus 3 squared. When you take that b term and you divide it by 2, whatever you get, that's what your trinomial is going to factor into. Okay, so if we look at 11, so first thing is x squared. Is it 1x squared? Yes. Second, constants on the other side. Yes. So you take the b term, which would be 8x. Divide 8 by 2, that's 4. You're going to square it, and you're going to add that to both sides. Why am I adding it to both sides? Because all you're doing is changing the way the expression looks, not its value. So what you do to one side, you have to do to the other side. Otherwise, your equation is not balanced. So now, again, you could sit here and try to figure out what does this trinomial factor to. But I already know. The answer is right there. It's x plus 4 squared. If that was a negative 4, it'd be x minus 4. If it was a 10, it'd be x plus 10. When you divide the b term by 2, that will tell you what it factors to. That's one of the nice things about completing the square. And then on the right side, negative 2 plus 16 is 14. And again, this is just an introduction because tomorrow, or when we work on these notes next on 7.2, we're going to use this to help us graph circles. Okay, number 12. So again, first thing, the a term, the x squared is a 1, perfect. Constants on the other side, perfect. So I'm going to divide the b term by 2. Remember, the b term is negative 16. So that would be negative 8. I'm going to square it. So 64 and 64. So when I divide it by 2 and square it, I add that number to both sides. Because again, I'm making the equation look different, but the value is still the same. So I have to add the same number to both sides. So what does this trinomial, x squared minus 16x plus 64, factor into? Now you could sit here and figure it out, or you could literally look at the part when you divide it by 2. So this would be x minus 8 squared. One of the biggest mistakes is students forget the signs. So you have to be careful. You take the b term. The b term is negative 16. So you're dividing by negative 16 by 2 to get negative 8. So it factors to negative 8, that quantity squared. And then on the right, all we do is take our 64, add it together with the 17, and we have 81. Okay, and then number 13, same thing. X squared, is it a 1? Yes. Again, it's not always going to be a 1, so you're going to have to sometimes use division or multiplication to make it a 1, but that'll come in down the road. The constant's on the other side, so I'm going to divide the b term by 2, so it's negative 5 halves. I'm going to square it and add that to both sides. So negative 5 halves squared would be 25 over 4. 25 over 4. Now some of you are like, oh my gosh, really? We have to try to factor this trinomial? Are you kidding me? Well, that's why if you pay attention to the pattern of whatever the b term is and you divide it by 2, whatever that expression is, that's what it factors to. So I know, without having to do any work, that that's what that trinomial factors to. And then on the right side, all we do is add those two fractions together. Good news is they both have the same denominator. So 25 and 3 would be 28 over 4. And then you take 28. Does it go into 4? Right? And it does. 7 times. So there you go. So this is just kind of a refresher of completing the square, because you've seen this in math too. But this is just kind of refreshing your mind on the beginning process. We'll apply it more when we get to 7.2 notes. Okay, rewrite the following as x minus a squared equals b by completing the square. So 14 looks different than the last 4. Right? It does have 1x squared, and it does have a b term, but now the constant is on the wrong side. So I'm going to move the constant over. So I want this to look just like the last few problems that we have done. Notice how as I write this, I always leave space on both sides. That's just a reminder that I need to add the same number to both sides. It's a filler. I want to make sure that's completely filled in so I don't forget anything. So now I can take the b term, divide by 2, which is 3, square it, add that to both sides. So I'm adding 9. So this factors to x plus 3 squared, and then 11 plus 9 is 20. Again, the two mistakes that most students make. First is when they're dividing, they mess up and forget the sign, right? Usually only happens when it's a negative. Second mistake is students don't add the same number to both sides. So what do I mean by that? They don't add 9 to both sides. They add it to the left, but they forget to add it to the right, and a lot of times you get the answer of equals 11. No, that's not the case. You're not changing the value of the equation. You're changing its appearance. So if you do something to the left side, you have to do the exact same thing to the right to preserve the balance. So I added 9 to the left. I have to add 9 to the right. So now the whole thing looks different, but it's still the same value. So this is just a little quick introduction to completing the square. We're going to use this more on our circles in our next lesson. So please go through, look at it again, answer the essential question at the top as you write your summary at the end of your notes. Have a great day.